Hey guys, Miss Bodechon here. So this is part 2 of AKS 8D, which is just all about mechanical advantage. It's going to be really quick and easy. So it's asking us what is the equation for mechanical advantage and just what is mechanical advantage altogether. So let's go ahead and look at that. So this is the equation for mechanical advantage, MA standing for mechanical advantage. You're going to do the output force divided by the input force. Now notice I wrote some different verbiage on here because we do have different ways we can say these same words. So output force we can also say is the resistance, or we can call it the load, okay? So in other words, this is what the machine is doing for us, or what the machine is doing to move the load, okay? Divided by the input force, which is just the effort that you're actually putting into the machine, okay? Mechanical advantage of a machine is how many times it amplifies your effort force. So if I put a certain amount of my muscle force, my effort into a machine, it's going to multiply that by a certain number, and that number is the mechanical advantage of the machine. So let me show you an example. Here we have this lady, and she's moving, so she's using a dolly to move her boxes, right? It would take a long time to move each one of these boxes individually, right? You have to do it one by one, especially if they're very heavy, and it would cause you to use a lot of your muscle force and it would take longer. So in order to do this much more efficiently and not use as much muscle, we use a dolly, which is a simple machine, okay? Now, just to go over this, we have wheel and axles on this dolly, and this dolly is also working as a lever, right? So our fulcrum would be right here at the bottom, which is our pivot point. Aside from that, let's talk about the mechanical advantage. So what she's actually doing is she's putting effort force into the machine, which is just called your input force. It's what you're putting into the machine, right? So she's doing 50 newtons worth of input force. And in turn, what the machine is doing for her is the output force. So the output force is the machine is actually doing 500 newtons worth of force with that 50 that she put in, okay? So that's amazing. It definitely helps us out. So it says calculate the mechanical advantage. Well, we know that we have to do our output force divided by our input force. So the output force is 500 divided by our input force 50. If we were to put that in a calculator, we would get 10. Notice there are no units on this number, okay? And there are no units for mechanical advantage. That's because it's just a number that the machine is given to multiply our force by. So whatever force we put into the machine, we can multiply it by 10, and that's going to be what the machine does for us. That's the output force, okay? So there are no units here. If a simple machine has a mechanical advantage of 3, what does that mean? So it means the machine multiplies the applied force by 3, and it's going to give you that much force coming out of the machine. So let's look at our next thing here. So it says the mechanical advantage of the lever is the ratio of the distances of the two arms of the lever. So in this case, we're just looking at levers. So the mechanical advantage of different machines can be calculated a little bit differently. We're just going to look at this lever just to understand it a little bit more. So we're going to do the length of the effort arm divided by the length of the load arm. Remember, the load is what you're actually trying to move. In this case, we're trying to move a cat, because why not? Try to move a cat, right? In order to work a lever, we have to have a fulcrum. And so our lever is based on some kind of fixed point, and then the effort arm is where we're actually pushing down so that our cat can push up, right? So it says calculate the mechanical advantage of all 3 levers, and then explain the force distance trade-off with your results. So here we go. So let me move this. And this is our calculations of all 3 levers. We are going to do our effort force divided by our load. In this case, both of them are 6. So 6 divided by 6 equals 1, right? Mechanical advantage of 1 for this lever. B, we have our effort arm being 3 divided by our load arm being 9, because it's the one next to the cat, which is our load, right? So 3 divided by 9 equals 0.3, which is not very much. This lever is not helping you out, okay? Not very much at all. In fact, it's making it harder for you than it would be just otherwise. And then C, your effort is going to be 10 meters, and your load is only going to be 2. So if we divide that, we get 5. So which lever is the one that we really want to use? We want to use the one with the highest number mechanical advantage, because that's going to be the one that amplifies our force the most, because we multiplied, right? So C is definitely the one that we want to use. So if you have the fulcrum closer to your load, that's the least amount of force that you're going to have to put in, because it has the highest mechanical advantage, so it will multiply your force the very most out of any of them. Okay. Notice B, having the fulcrum really, really close to your effort arm where you're actually pushing down makes it harder than if you were just trying to do this without a lever in the first place. Okay. And that's all stated here. The closer the fulcrum triangle, right, this little triangle, is to the object, the more distance and the less force you have to use to lift the object, because the mechanical advantage is higher. So if you have any questions on this, you guys, just let me know.